Hello, welcome to our presentation. On this occasion, we will discuss about the civil engineering problem. Next. The problem is described as follows. Two settlements A and B are separated distant enough by a deep valley. Geographically, village A is located next to a lake, which in this scenario function as the settlement's water source. However, as illustrated in the figure, village A lacks space for farming purpose, whereas village B is located on the other end of the valley, where land is abundant but lacking consistent water source. Next. To delve deeper into the problem, we will analyze what the main problem is on this scenario. First of all, we will look at the village A's perspective. As mentioned previously, village A's land is too small for farming, therefore limiting the potential of having them independently produce their own food. Next, we will look at village B. Since there aren't any consistent water source in village B, they can only rely on occasional rainfall for their farm, limiting them to only be able to harvest seasonally. Now we look at a bigger perspective. The two villages are separated, which means there can't be any mobilization between the 2 points. Any interaction, such as delivering food supply from village B to A, will be challenging. The same can be said as for transferring water from village A to B. Due to this, a critical problem arises, which is hunger for both villages. Next.
As Audika mentioned before, our problem is about water and food resources. So our group have a solution of creating an aqueduct. Aqueduct is a channeling conduit built to convey water. It is built to specially convey water streams across the valley. The water streams is changed in this case for a lake as its water source. And the Roman aqueduct, what we specifically do in this solution is a aqueduct that have been around since 300 BCE and is considered the greatest aqueduct in the ancient world. Next. Agriculture. Agriculture is the art and science of cultivating the soil, growing crops, raising livestock. It includes preparation of plant and animal products for people to use and their distribution to market. There are certain aspects to look for agriculture, such as climate, soil, and sustainability. Water is the most crucial part of the agriculture. Plants, such as crops in agriculture, need water to survive. And how does water revolves around plants is water in the ground, go to the root system, and from the root system, it goes to the xylem capillaries, where the water is transported to the leaf, and in the leaf will be hit by a sun ray. Then there is photosynthesis. The photosynthesis creates food for the plants, and food is distributed by the phloem capillaries to all parts of the plants, giving life to the plants. Next, food supply chain. The food supply chain is stage of food that goes through all of its process, from the producing process to its consumption process. From the graph below, we can see how food supply chains work. First, farmer. Second, producer, distributor, retailer, and last is consumer. Where the money goes, where the food goes, the money goes. So there is movement of food and the movement of money. Next. Chapter 3, design methodology. Our group create a 3-phase of design methodology. First is analytical, second is creative, and third one is executive phase. The first analytical is we analyze the problem and we analyze what solution that could be given and what is the user of the solution that might be using our construction and so on and so on. The second is creative phase. Creative phase, we brainstorm with design concept, and from the design concept, we created a weighing measurement, such as the graph below, economic, aesthetic, materials, and functionality. We chose the best one, and from that, we chose the design alternative from that concept, and also weighing that design alternative. The last one is executive process. Executive process is last part where we create a 3D and 2D model of our design. Next.
So as we've mentioned before, our design is inspired from the ancient Roman aqueduct, but with a wider space so that vehicles and pedestrians can pass through. Since we don't know the width and dimensions of the valley, we had to assume that it had a width of 400 meters and a depth from 50 to 75 meters. So yeah, the bridge has to be 400 meters long. The road on the bridge is 3 meters wide with 2 lanes and 2 sidewalks that have a width of 1.5 meters each. The functional area of the pillars is 9 square meters, and the arch has a cross-sectional area of 5 square meters. So when a 2D and 3D model were made.
So here we have the side elevation view of the aqueduct, and from there the general components can be seen, which is the source, the bridge, and the water bridge. Next, we have the closer view of the main bridge of the aqueduct, in which the road surface or pavement along the safety barriers can be observed, especially the iconic arches for supporting the whole structure. Here we have the top view of the aqueduct, which showcase the main conduit for the transportation of water, of the water source. Next, we finally have here the close-up view of the water intake, which is utilized for the early stage of water collection process from its source, along with the view of the pipeline that is connected to the main conduit.
Hello, in this video I will show you a short simulation of our design concept, which is a Roman aqueduct. First off, let me explain the problems once more. There are two villages, village A and village B. In village A, there is a lot of supply of water, but there is no farmlands and agriculture. While in village B, there are a lot of farmlands and high agriculture potential, but there is a very limited supply of water. So we decided to connect both villages using a Roman aqueduct. The first component of our Roman aqueduct is intake, which we put in the source of water in village A, which will then run down into the conduit part of our aqueduct, which is held up by pillars, which is connected to the road, which is used for transport between the villages. We hope that this design could satisfy the needs of transportation and also fulfill the water needs of village B.
So as mentioned before, the purpose of this aqueduct is for transportation. Furthermore, the aqueduct also acts as a transferring vessel for supplying water from the lake near village A to village B, so that village A could get nutritious food supplies from village B and interact with the people of village B. We had this many pillars compared to other bridges because the load exerted for the bridge would be great, we predicted. And the water pipe also utilizes the slope of water source to which we to increase the water flow. So here are the materials and tools needed to make the bridge. Next, please. For the construction cost estimation, we took most crucial parts of the aqueduct, and we got that total price would be $3 million US. Yeah, about that much. Next.
This is our frame for the construction. We estimated 200 days from start to finish. This is important because we need to reach certain milestone in each of our process of construction. Next. And from that milestone, from that work frame, we can determine what certain equipment that we need to rent from for the construction. And this is the total of our renting is $1.2 million. Next.
So to conclude the analysis and the result, the implementation of the design is able to optimally overcome the inversely proportional problems between the two villages in each valley. So the design we chose is a Roman aqueduct, which is sufficient enough to overcome the issue of transportation and resource management whilst maintaining the sustainability with friendly manners towards the environment.
As for the final evaluation based on our design results, there are several evaluations for our design. First is we need to know the maximum weight and shear force the bridge and that handle. Second is the specification of farmland to know what kind of crops and what type of plants that are going to be grown on village B. Third is information regarding the height and volume of water that is in village A, so we could know exactly how much the water source is. And finally, the difference between the water source in village B. So we can find the consistency of the water source and how much we can supply to village B. Information regarding the constructions and worker durations has been displayed in previous slides.